We've got blinky lights and no gremlins. Welcome to Hack-A-Week. Back on the workbench here, troubleshooting, and realized I have this transistor in backwards. I mean, it will work that way, but it's not ideal for a PNP. The emitter should be on the supply side. The collector should be on the load side. I had it the other way around. So I'm going to put this back in, flip it around the other way, and then we'll check everything out one more time. See if that makes any difference with the problem I've been having. Okay, let's power it up. I got nothing blinking now except for the first 555. Okay, the circuit's running right now. I'm going to take this little red LED and do a little testing here. Let's make sure we've got a signal getting to pin 8. Yeah, it's blinking. Now let's go between ground and pin 3. Make sure that this 555 has an output. Yeah, it's doing what it should be doing. Let's check the other one now. This is the one that's driven over here by the transistor when it goes high. Let's see what we've got on that one. Interesting. It's running constantly. It's never switching back off. Okay. I'm going to flip that transistor back the other way. I got rid of the PNP and put an NPN in here, and its arrangement is an inverting buffer. So the collector goes up here to the 12 volt rail. There's a 1K resistor there, and let's see, the base is connected to the output, pin 3, the output on the 555, the first one. The emitter goes to ground. I tested out just this little circuit on the breadboard. When I apply a ground here, I get a positive voltage out here. So, in theory, I know that it's inverting the voltage basically. Negative in, positive out from the 12 volt rail. However, here it is in the circuit. You can see the first 555 is doing the green blink, and then the second one goes blinky blink, and it lights up that LED off from the MOSFET. But the second or the third 555 isn't doing a thing. There's no output here. There's no output at the LED, but a little bit of a dim glow, which is strange. And I changed out that MOSFET. I can disconnect this MOSFET from the circuit and just bypass it and put 12 volts at the gate, and it turns on the light. So I know that the MOSFET is working, but I don't have anything going here. I got the scope hooked up though, the old Tektronix 453. So let's take a look at that as we probe around a little. Okay, let's take a look at this. First, let's just go to pin 8, which is 12 volts on the first 555. And it's running up there at 12 volts. I know you can't really see the divisions here, but I've got it set at 1 volt per division, and that is 12 volts, trust me. Now let's go to pin 3, the pulsed output on the first 555. And it's running at about 8 volts. Staying on for about a half a second. Let's go over to pin 8 on the second 555, and of course that's the same thing because that first one is feeding it 12 volts from pin 3. Now on the second 555, here's the output on pin 3, and you can see that it's pulsed about a 50% duty cycle, and it's running about, let's see, probably about 6.5, maybe 7 volts. Okay, now that powers up the first MOSFET and the first LEDs just fine, no problem at all. Now let's go over to pin 8 on the third 555. Now this is getting voltage from that inverting buffer, and that looks really weird. It's only going up to, it's going up to about, damn. Well, it's a pulse. It's not a clean, solid voltage, which is a little odd. It's only going up to maybe, well, on those high peaks, it's about 5.2 volts maybe, and on the lows, it's down around 3.5 or 4. And it's a really odd waveform. It's not even 50% duty cycle. I don't know why it's doing that. That's really weird. It shouldn't do that. If I had a good clean 6 to 8 volt signal there, I think that third one would be turning on just fine and everything would function okay. Let's go to pin 3 on the third 555 and see what's coming out of there. There is a pulse coming out of there, but it's the wrong kind of a pulse, and it's only 2 volts when it is on. That's just wrong. So it looks like that inverting buffer is not the answer here to make that third 555 turn on. I need to come up with something else. Okay, I went back to that original thing where I'm taking the signal that's coming off from that first 555 when it goes low and sending the ground from pin 3 when it's low over to the third 555 and switching the ground to that third 555. I'm leaving the 12 volts connected on that 555 and switching the ground via the first 555 when it goes low. Problem with that was that it was staying bright. So what I did was I put a diode in there, just a small switching diode, and I pointed the cathode towards the first 555. That way it doesn't let the back voltage light up the LEDs. So it's still a little bit weird in that this one is flashing a little bit faster rate than this one does, and it's still not going quite completely out. It stays dimly lit. I got a theory on that though. This guy right here, I've got a diode connected, to monitor everything, right? The little blinky one that's going to stay inside on the box that all the guts go into. And it blinks along with this one. But it's connected right up at pin 3 of the 555, and it also goes to ground. So this could be doing a little bit of back voltage stuff. See how it stays on in between blinks? But this one goes completely out. So I'm going to move the source of where this gets its voltage to, let's see, the output on the MOSFET and see if that makes a difference. Well, right now it's completely disconnected and it's not making a difference. These are still staying on dim in between flashes. See that little bit of dim light? So they're not turning completely off. And I want you to go completely off, damn it. I'll figure this out if it takes me all week. Okie dokie, let's do a little poking around on the MOSFETs and look at it on the scope. This is the one that turns off the way it should, the first MOSFET. This is the drain. This is the lead that turns on. There it is. Nice square wave coming out. It rises to about 7 volts. Now let's go to the one that's got the wonky problem of not going out all the way. That rises only to about 6, maybe. Yeah, that's easily 7 volts. And the one that's got the problem rises to 6. Okay. Now let's look at the gate. Here's the gate on the one that works okay. Whoops, wait a minute. Okay, there we go. It's got a nice pulse on it from, it goes up to about probably 7 volts. And it goes back down to a good solid 0 volts. Now let's go to the one that's got the problem. This is the gate on that one. Oh, look at that. That's not going all the way back down to 0 volts, and it's actually rising higher. It's rising up to, gosh, almost 10 volts, and it's coming back down to only 3. So it's floating at 3 when it's off, and that's what's making that LED stay dimly lit. Now this is pin 3 of the last 555. It's also floating above ground. Well, it turns out, after all that poking around, all that messing around, all of those guesses by everyone online as to what the hell was making this LED array stay dimly lit, it was a bad MOSFET. Yep, even though that thing was a new one I put in, and it was damaged way back when I hooked everything up backwards without putting in a protection diode, silly me. It fried that MOSFET. I changed this one out, and somewhere along the line, that one got messed up too. So I've pulled it out of the board right now, and I've got other ones here. Went down to Radio Shack, bought the last 2 they had. I've got some ordered from Tata Electronics. They just didn't get here yet. But I did get my P-channel MOSFETs from Allied Electronics. Allied Electronics, again, comes to the rescue. Those guys are great, I'm telling you. They've got everything there that you need. It's for real electronic techie people. It's not so much geared towards trying to sell stuff to hobby people. They just have damn good parts at damn good prices, and they ship pretty quick. So I've got some P-channel MOSFETs here. There they are. Happy little P-channel MOSFETs. They work the other way around. They source out positive voltage, and the gate has to be pulled to ground, not pulled up to the voltage of the positive rail. So what I've done here is breadboard up a little circuit to test out that P-channel MOSFET. Let's check it out. Okay, we are zoomed in. We've got a stable oscillator circuit set up here. It blinks about 1.5 seconds on, 1.5 seconds off. Pin 3 goes over here and triggers the gate on this P-channel MOSFET when pin 3 goes low, when it goes to ground. When it goes high, it will turn on this LED. But when it goes low, comes over here, pulls down the gate to ground, and then switches 12 volts to this LED. Let's turn it on. And that one now lights up, and that one, see, back and forth. So that's the solution right there. So what I'm going to do is put a P-channel MOSFET in, and that's what will trigger the second 555. And replacing that other N-channel MOSFET that was bad should take care of that one LED array that was staying on. No, it wasn't the little pilot LED doing it. It wasn't all the other things people suggested. It just turned out to be a bad part. This is my original schematic, all hacked up, chopped up, got that silly little PNP in there, and bye. I'm starting over. So I drew it all up last night, started all over again. This is in pencil, much easier to make corrections on. And right there is the P-channel MOSFET. So if you want to pause and take a look at that, feel free to do so. And we'll move along with getting this onto the circuit board and seeing if it takes care of this little problem we had. I redid the PCB layout. You can see right there is the P-channel MOSFET that I stuck in there. So now I need to just put that on the circuit board and we're good to go. All right, everything is soldered back on the board. I've got a P-channel MOSFET here now doing the switching for that third 555. I replaced the N-channel MOSFET that was fried over here. So this is the moment where we throw the switch and it either works or we get magic smoke. Here goes. Lisa's here to watch too. Yay! Yay!
Yay! It works!
Awesome! Now I can stuff it all in a box. Just for fun, let's try varying the rate here with the potentiometer and see what we get. And go faster. And I put a 1K resistor on this so that it maxes out at 1K. Wow, that's pretty fast back and forth, huh? So that's the fastest it will flash, and that's with the potentiometer turned full clockwise. And if we slow down, we can slow this thing way down. That's fully counterclockwise at 20K. That's about 1 second on, 1 second off, roughly. All right, let's put it all in a box. You know, before I wrap it up here and put it back in the box, I want to show you the waveforms, just like we looked at last time. Let's look at the power supplies going to each one of these. First of all, the 12 volt power supply that goes to pin 8 on the first 555. That's a nice clean 12 volts. Let's check the second one. Of course, that's fed through pin 3, which is also connected to the P-channel MOSFET. There's a little bit of a square wave in it. That's kind of odd. Well, let's go over on the final 555 and let's take a look at the power on that one. That's pretty clean. Nice flat line right at 12 volts. Let's look at the outputs of those last two 555s. Pin 3 on the second 555. Nice little square waveform there. And pin 3 on the third 555. And a nice roughly 50% duty cycle. But that's a little weird, that that square wave. There's a tiny bit of ripple in it. See that? That's a little weird. I wonder if I can fix that. Maybe a diode in line there, which may help. I think it's because it's connected to that P-channel MOSFET. Let's take a look at that second 555's power now, the one that comes out of the P-channel MOSFET. What I did was I put a Zener diode before the gate with the anode pointing back at that first 555 pin 3. Of course, there's a 20 ohm resistor in series there too. Let's see. Let's check it out. That's the power going to the second 555. There it is. Nice flat line now. We got rid of that little square wave. So the Zener diode did the trick in there. One more little thing to add to the circuit. Then we'll box it up. I've got a layout here on the cover where the potentiometer will go here, the switch here, the green indicator light there, and then the left, right, red lights on either side. Got a 1/4 inch drill chucked up in here. The LED holders that I use require a 1/4 inch hole. So I'll just drill all these holes out now with a 1/4 inch drill. For the hole for the switch, I'd take the 1/4 inch drill bit and just move it back and forth and get it elongated a bit, and then use a number 11 X-Acto and slice it out square. Like that. That takes care of the cover. Now as far as the box, the rest of the box, I have to, let's see, I've got to have a hole for the power and another two for the left and right lights. So we'll just drill, let's see, we'll drill one hole for the power. We'll do that right here. And then we'll do the other two over on this side for the two lights. Now for the power switch, I'm just going to take the lead for the power, and I guess I'll just cut it right here. Need to leave enough room so that when I pull the cover off to do anything on this, I can still lift everything out okay. So that should be enough to be able to reach in there. I'll cut it right about here. Just cut the positive cable only. And we'll strip each end of that and solder it up to the switch. Now we can start mounting everything up. Let's get the circuit board mounted up first. Just put a screw through that corner hole and drop it down in there. Screw it down to that corner mounting point. Now we'll get the potentiometer next. Got a knob to put on there that's just got a set screw on it. So these LED holders, you snap them into place first. Let's see, we get the green one in, that goes in the middle. And they just snap in, that's that. We got one over here. And the last one goes here. There we go. Everything's mounted on the cover. Now we'll just run the wires out through the holes. Before we run the wires through the holes, let's tie a little knot here so that we don't accidentally yank the wire too hard and pull on the circuit board. Just a simple knot in the wire does the trick. I extended the wires on the light leads, hooked the lights up, and I put a cigarette lighter adapter on here before we go put it in the car. This way it can be hooked up in any car real quickly. There's the box sitting on the seat. It's plugged in over here to the auxiliary power, the cigarette lighter. And I just stuck the two lights vertical in the window. They're not really that bright because they're just marker lights. You could probably buy some better lights than this, something that's high intensity LEDs. Let's go see what it looks like from the outside. You're seeing it through the windshield glass, so of course that diminishes the brightness considerably. And in fact, it doesn't even really show up that much on the camera right now, but you can see them blinking away right there. So this is in full daylight, proof of concept. They're mounted up in the grill. I've got the box outside the car right now, so you know, whatever. It's just to show where they could be mounted and that they do indeed blink back and forth. You could probably find some super bright LEDs that would be like 100 times brighter than these are. All these are is just little conventional LEDs mounted in a really simple array. They're meant for nothing more than a marker light. But I'm gonna see if I can source out something that's a little bit better on the net and get that in the parts list. But hey, you know, the circuit works. It's really good. It's going to be able to do the job. Well, our little circuit works fine, even though the lights aren't quite bright enough for daytime viewing. They'd be okay at night. But like I said, I'm going to see if I can source out some brighter, super bright LEDs, and this would be a pretty rockin' little light setup on your dashboard for emergency vehicles. Really didn't expect this project to go into 3 parts. Thought it would be a pretty slam bam one-time thing, but it's kind of fun that it did go like it did, and I'd like to thank everybody who contributed and gave me advice and offered suggestions in the comments on YouTube. I don't think I've ever done a video where I had so much interaction between myself and viewers and people actually building it out of breadboard, actually putting it together and doing some testing, running simulations in some of the software programs that are out there, writing their own schematic. One person even built their own version and used op amps to do some of the switching instead. So kudos to you guys for doing all that work. I really appreciate it. And along the way, I learned a few things. That P-channel MOSFET really did the trick to turn on that second 555. The old Tektronix 453 scope got to get used. Even though it's an old analog scope, you can see it still does the job. It helped me do some troubleshooting on this project. So I guess that's about it. If you want to build this, I will put together a final schematic and a parts list on the Hack-A-Week page. Just look down below there in the video description. You'll find the link to that page. And don't forget, if you like the videos and you want to donate, just go over to the website, click the donate button, and do as you will. I guess that's it. And until next time. I soldered everything up on, yep, that's what it did. Soldered it. Solder. I really didn't think this project would go on this long into 3 parts, but it did, and I'd really like to have, yeah. Well, not really as bright as we would hope to have them work out there in the daylight, but hey, the soundness of the shit. Lots of people asked why didn't I use the control pin, and it had to do with wanting to use that first 5-5 switching 5-5-5-5-5-5-5.